Hi, today we're going to look at the log files you can get out of Fastest Lap Calculator. And one of the loggings you can get is the suspension forces, and for the suspension forces to be right you need to know approximately how much the rider is leaning outside of the bike or hanging out while riding, and there's an input for this in the bike settings, and in this case it's set to 20%, meaning that if the bike is leaning 45 degrees the rider will lean 9 degrees more, so the center of gravity of the rider will lean 54 degrees while the bike is leaning 45 degrees, and the total center of gravity will be a calculation of those two, the bike and the rider. So if we want to get the log file, we have a button for the log file here, and this is the selection what you get in the log file. You get the calculation point number, which is the same as you have in the point data here, the distance, the time from when the calculation started, speed in meter per second, speed in kilometers per hour, throttle, gear, engine RPM, altitude, suspension force back and front, perpendicular force, which is the force giving the friction, the force perpendicular to the ground. So if the ground is leaning, it's the perpendicular force to that leaning ground. And you also get the coordinates in meters. The first thing you have to do is to select where to put the file, and I'll write over this one. And I also need to tell it how long I want to have between the points it's spitting out. So if I take one measurement every meter, I export like this, and export is complete. Now I can start analyzing. This is the log file coming out of Fastest Lap Calculator, and when we have the log file in table format like this, it's very easy to make diagrams out of it. Here I have made a diagram of the suspension forces, suspension force front, suspension force back, and it's the suspension forces riding through this corner. And we can see we're on the gas until here, and here we're going full braking. We release the brakes approximately until here, and then we're getting on the throttle and out of the corner. And what we can see here is that the suspension force back is higher than the suspension force front while we're on the gas, and exactly here is here when we go on the brakes, and it's a sudden shift where all the weight is transferred to the front of the bike, and this is braking into the corner, and in approximately here we release the brakes, so the brakes are gradually released until here, which is here. And what we can see here is that the load on the front is going down a little bit, but not so much, since we are braking into the corner, so we are releasing the brake at the same time as we lean the bike. The braking forces are exchanged to the forces coming from turning the bike, and this is going through the turn. It's a little bit up and down in the calculation. It's calculating stepwise, so you have a little bit of noise on the calculation. In a real measurement it will look very similar, because then the noise are all the small shifts in the ground which are not there in a simulation. And then when we go out on the corner, we go on the gas, and as you can see, the back wheel is taking more load while the front wheel is taking less load, but also the total load on the bike decreases when the corner opens up. So even though the back wheel is taking more load, it's not like a very big shift from in this corner, which is also very much banked. I have put 10 degrees banking in that corner, and that adds a lot to the suspension forces. Another very useful analysis you can make from the log file is if you have access to the logged speed while riding. That could be from a GPS or from any other means of logging. In this example, the logged speed is blue, while the calculated speed is brownish, and I have tuned the calculation to give the same lap time as the logged speed. So in average, the calculation is as fast as the rider. And if we look in the first two corners of this calculation, we can see that in the first corner the rider is a bit slower than the calculation, while in the second corner the rider is actually a little bit faster. So if this rider now wants to improve his lap time, it's a good idea to start increasing the speed in the first corner rather than doing it in the second corner, where you already are above the theoretical calculation. Since it's below in the first corner, it's definitely more to take in that corner. It's longer to the physical limits than it is in the second corner. This was all for today. Thank you very much.